Okay, everyone, please welcome Roy Derks.
Thank you.
He wasn't ready.
I was almost ready, but my slides weren't. Thank you. So this talk will be about generative AI for web developers. So I'd like to emphasize it's for web developers and not for data scientists, and you'll see why in a bit. But first, I'm happy to be back. I've been at some of these CityJS conferences, and it's nice to see that they're growing every year. And this year I also did a workshop on GenAI, so I got some new inspiration for this talk from the attendees there as well. So I'd like to say a lot has changed in how we use AI in software development, or basically software development has changed because we're using AI now. I was thinking back about the things I've been doing in my career or in learning stuff. And in 2016, I was actually doing a training around machine learning. And if you look on the right side, you can basically see what I was learning during this course. I was learning how to distinguish these Chihuahua dogs from actually blueberry muffins. And this was AI in 2016. So 8 years ago, we weren't able to answer questions about cities or your career or whatever you need to do next whenever a bird shits on you, like those ones we saw there. It was mathematics, statistics, computer science, and you need to know all these things in order to actually get some inspiration from AI. And if you look at what it's doing today, or it has been doing for the past 1-2 years, it's something simpler, and it's something that, at least to us, feels simpler. Under the hood, it's still doing all those complicated things for which you need to be really smart, which I don't think I am, or at least maybe I am some days. So today, it's all GPTs and code assistants and AI making our life easier rather than helping us to figure out the difference between two types of images that look alike, or maybe a type of text that looks like a different type of text. So my name is Roy. I've been doing tons of stuff. I've been doing a lot with React and GraphQL and TypeScript in the last few years. And for the past 2 years, I've been doing a lot of things around AI and GenAI. And I also like to say I've been doing AI all my life because I've been writing FL statements since, well, basically the first line of code I wrote. So if you want to know more about me, feel free to find me on some of these channels and connect with me, but I'll be here all day as well. So to go back to how AI has changed things we do, I'd like to say it has changed how developers write code. So I'd like to get some hands for developers that are using code assistants or are using GPTs in their work. Oh, that's great. So that's almost all of you. And then I hope your company isn't limiting you in using it, or maybe if you're studying, you're not limiting in using these code assistants yourself. But then I've got a follow-up question, which might be a bit more, well, a bit more difficult to answer. So do you actually know what's happening when you ask a question to these GPTs or when you're typing in your terminal? Do some of you have actually built connections to AI themselves? Well, I see some small hands. That's good. That's good. So let's look at a typical setup for a GPT. You have your question, which is maybe asked by a human or maybe asked by a different system. And then you have an answer that is coming from the LLM. So there are things happening in between. And it looks like most of you don't know what's happening in between, or maybe you can make an educated guess on what's happening in between. So what's happening in between is still the old things. You need to know machine learning, or there needs to be a model somewhere running, either trained by you or trained by someone else. You need to know about computer science, about statistics, and about math. And the good thing is, at least the good thing about these LLMs and these GPTs that are built on top of them, you don't have to be a data scientist today in order to work with them. Not only from interfacing with an LLM by asking a question and getting an answer, but also when you build applications on top of these LLMs, or you build integrations with LLMs, you no longer need to be a data scientist. Of course, it's good to know what you're doing, but you don't need to have this solid understanding of statistics anymore. So instead, I can say we can all be AI engineers. And when I talk about AI engineers, you can probably call it all sorts of things. So the way I think about it, and there are some other people that are thinking similar things, so I stole a bit from them, and I came up with my own definitions as well. So an AI engineer to me is a developer that works with an LLM rather than a developer that develops an LLM. If you're developing LLMs, you're probably a data scientist or a data engineer or something in that category. Whereas an AI engineer is someone working with the LLM, either building stuff on top of them, building stuff around it, or maybe influencing your day-to-day job with information coming from these different LLMs. And this is all possible because we have these foundation models. So to look back at what I showed you in 2016, if you were using a model, you had to train this model yourself, or someone trained the model on a very specific use case. So I trained a model to distinguish these chihuahuas from blueberry muffins. But these foundation models are trained on basically anything. So these are encyclopedias that can answer all sorts of questions, and some of them are fine-tuned later on for specific use cases. But because these things are so broad, you can use them for basically anything. And if you, as a developer, like to interface with these different models, there's lots of choices you can make. There are open source models, there are closed source models, there are models that are available through all sorts of providers, and then there's models that only run locally in your computer. So there is someone here, and I think Google actually rebranded them to Gemini. So all these models are available somewhere, either really cheap or by getting them to run on your own systems. But as a developer, you're almost never directly interfacing with these models, because it would mean you need to have it running somewhere where you can access it directly. So typically, you would interact with these through APIs or SDKs. And if you're looking at providers of these models, you can typically find that they have REST APIs or SDKs that you can use. But today I'll be showing you how LangChain works, and LangChain is actually a collection of SDKs, or it's one SDK, but it's an SDK that has a collection of functions to interface with these models and a lot of abstractions, so you don't need to build all these nitty-gritty details yourself. So we'll be using some LangChain, and then we'll be using this in a, not an Angular application, but basically any JS front end you can imagine. Because it's an SDK, it's just JavaScript. Could also be Python, but I'm assuming most of you are not working with Python. So in your JS front end, you can work with the LangChain SDKs, and then these SDKs will make sure there's a connection to all these different LLMs. And the good thing is also, these are abstractions, so you can swap out one LLM with the other in case you decide to move to a different provider at some point. So this means every developer, including yourself, can start developing AI applications. And the only thing you need to do is install some stuff from NPM, which I'm pretty sure you can all do. There's the core LangChain library that has most of the things you need, and then per LLM provider, there would be a separate library within the OpenAI within the LangChain namespace that you can use to install the connection to those specific providers. And there are multiple patterns to actually go from question to an answer. I'm pretty sure you all heard about prompt engineering and writing prompts and how it's different from just asking a question, but actually asking a question in a structured way with a set of instructions to get better results. So prompt engineering is basically this. And if you're using ChatGPT and you're just typing your question there, you're actually writing a prompt inside a prompt if you think it's prompt engineering to type stuff in ChatGPT. So a prompt is natural language, which is the language we all speak. And this language will describe the task the LLM should undertake. If you're asking a question to ChatGPT, it actually has a prompt defined already, and your question is just part of that prompt. So prompt engineering is the process of structuring these prompts in a way that you'll get the best possible answer to your question, at least based on your preferences. Because it's always an educated guess to figure out if the answer is any good. There's a whole range of tools you can use in order to figure out if the results are good, but that's a different talk. So typically it will work like this. You ask your question will be injected into a prompt, and this prompt will include your question and instructions. And this will all go to the LLM, and the LLM will give you the answer to your question by using the prompt instructions as well. So an example could be, instead of asking ChatGPT, like, what places should you visit in London, you can also tell it to take the role of a personal travel assistant. And by doing so, it will try and tailor to your question in the way that a personal travel assistant would do. And this is something we call zero-shot prompting, because you're asking a question and you're going to assume the LLM will give you the answer in a somewhat desirable format. But quite often you'll get something weird. You get inconsistent answers. One time it will be 200 tokens, and tokens is not characters. So let's say one time you'll get a 200-character response, and the other time it will be 400. And maybe at some point the LLM could tell you, you shouldn't visit London, because maybe the LLM feels like it's not a good place to visit. So zero-shot prompting is something you can easily implement in LangChain. I'm going to spare you the details of this code because I'm showing an example later on that's a bit more advanced. But it's basically all concentrated around importing stuff from LangChain. And the SDK is pretty complete. And let's say these are 10 lines of code in order to interface with an LLM from a JavaScript application. But there are more complicated, more complex things you can do. So instead of zero-shot prompting, which is fine if you're just asking a question and you don't really care about the response, there's something which we call n-shot prompting. And you can also call it few-shot prompting. But this is a scenario where you would ask the LLM a question, and in your prompt you will define some examples. Because maybe you want to have the best restaurants in Amsterdam, which is the city where I live. But you want the LLM to structure it in such a format where it comma separates 3 of the best restaurants it can find. And maybe if you ask it what's the best time of the year to visit the Netherlands, you don't want it to respond you don't want a response to just be summer or April or May or whatever thing you can think of. You want it to be a sentence that explains the best season for tourists to visit the Netherlands is XYZ. And by providing these examples, you're going to force the LLM to structure their responses to your examples that you include in the prompt. So this is very powerful, and when I was running the workshop, we were actually showing how you can work with this to phrase your results in such a way that you can also integrate it in applications. Because, as I said before, LLMs will come up with their own solutions to your problems. They're going to come up with something that might be the most desirable for most people, but not for your specific use case. So by doing this few-shot prompting or n-shot prompting, you can force the LLM to be more reliable for your specific use case. So if you want just one word to be returned, you can give it some examples that include just one word in the response. And there are way more examples of prompt engineering. If you're working with ChatGPT and you're asking multiple questions, you're probably doing chain of thought prompting. So this is where you ask a question, a follow-up question, you're maybe giving different scenarios, which could be 3 of thoughts. There's also React prompting, where you are going to rely on some tools. And there's all sorts of prompting. There's a prompting guide, which you can find using this QR code, which explains how to do all these different things. And there might be some examples in there that you can try out yourself as well. But prompt engineering is a whole different world. And I sort of feel like when ChatGPT started, everyone was saying in a few years we'll all be prompt engineers or senior prompt engineers, or whatever you like to call it. I think we're going faster than that, and in a few years we maybe don't even care about prompt engineering anymore because we're all writing our own applications and prompting has become as simple as writing a function somewhere. So moving on, you probably want to give the LLM some additional context in order to best answer your question. Because that's one thing I often do in all these different code assistants or ChatGPTs. I'm going to give them some example code or some example text that I want them to summarize, or I want them to get some basic points out of there. And this is something you can also do by integrating the LLM through a LangChain or a different open source library or as a service library, because there are multiple around, with information coming from a vector database. And this is something we call RAG, which is Retrieval Augmented Generation. So this is where you make the LLM context aware of your own data. And there's multiple ways to make LLMs context aware. You could also fine-tune a model, but this is quite expensive and will take you a long time. Or you could provide all your documents directly in your prompt. But this can also be really expensive and can lead to very long leading times. So it looks something like this. I'm not going to go over all these different steps. And this is heavily simplified, by the way. If you're building RAG applications yourself, you probably know there's much more to it than just this, but this is a good starting point. So when you ask your question, it will be turned into embeddings. It's just basically a vectorization of your question. And I could explain all this, but I also want to be considerate of other people's time. But basically, it vectorizes your questions, so you can use semantic search in a vector database to find relevant context. And in this vector database, there would be data that you uploaded yourself. So this could be documents, it could be invoices, it could be data coming from your CRM or your CMS. And then the vector database will find the most relevant bits of data and inject it into your prompt. So your prompt is now no longer a set of instructions and your question, but it also includes relevant data that the LLM can use to best answer your question. So this will all go to the LLM, and then you will get your response back. There's some nitty-gritty details in there, and one of the most important things in there is the vector database. To be honest, I don't think you'll see big improvements if you switch to different vector databases, because in the end, they're all more or less the same. Some might be better, some might be worse, some might be easier for you to use, and some might be easier to use for someone else. But it's an important part here because it will help you to only condense the data to the parts that are actually relevant to your question. So before, you need to chunk your data into smaller pieces. You will store this in the vector database, and then later on, you can retrieve it using semantic search. So you can say this could also be a data engineering task if you work at a very big company. But because these tools became so easy today, it could be as simple as calling a REST API with your documents or putting it in a S3 bucket and then uploading it in a vector database. So maybe 5 years ago or 10 years ago, this would be a data engineering task. I say today this is something everyone that knows how to write code can do themselves. And LangChain can do all this for you. So I created a small example, and now I'm going to actually go back to VS Code. So I didn't have it on purpose, but let's see if it's the correct code. So I'll be going here. So this is one JavaScript file, and let's say it's pretty long. It's like 120 lines of code. I'm doing a couple of things here. I'm importing a bunch of libraries, and I'm setting up a connection to OpenAI because this is the model I'm using. But you can swap it out for basically any model that's available on the internet. You can define which model you're using, and you can also set the temperature. So this will help the LLM in determining how creative it should be or how strict it should be in answering your question. The first step is sort of storing my data in a vector database, and I'm using an in-memory vector database because I'm lazy and I didn't want to set up a remote connection to something else, or run a local vector database. I'm importing some data, which is just a text file that contains information about Amsterdam, which is the city I live in, and I'm storing this in my in-memory vector database. And then to actually get an answer based on what I have in my vector database, I need to write a prompt, and in this prompt I'm going to tell the LLM that I want to answer my question only using the relevant data. Because there's something in LLMs that you might have heard about, which is hallucination. So this is where the LLM gets creative. It tries to come up with an answer. You maybe noticed from some of your friends that think they know everything, and then they just tell you things that aren't incorrect, but you don't really know, so you just accept these things to be the truth. We don't want the LLM to do this, so we're going to tell the LLM only answer it based on the provided context. Then whenever you ask your question, I'm going to retrieve it from the vector database, and then somewhere here, my question will be injected. So if I run this code, and I'm going to share the repo with you later. I don't think I have actually a link to it, but that's fine. So this is my sample GPT to it. I will share the repo in a bit. And when I ask a question here, like what are the highlights in Amsterdam? I see you have some typos in there. Then it will take my question, vectorizes it, goes to the vector database, tries to find relevant context based on data I uploaded, and then passes this into a prompt to the LLM. It's a bit slow, but I hope my answer will be here. And here you can see it answers my question based on the relevant context. You actually want to test this for things like groundness or level of hallucination if you actually start using this. But you can also go to your data and figure out if it's there. So I can test this by see if my prompt engineering trick worked and only ask it to answer questions based on the data it has. So my data only has information on Amsterdam. So you can now see when I ask about London, it says it has no information on London because my data is about attractions in Amsterdam. So LangChain does all this for you in a couple of lines of code, and I'm going to share the repo with you, promise. But RAG is not the only way to make LLMs context-aware. You can also do training and fine-tuning of your own models, which takes long and is expensive. So RAG is like a really good case, especially for us web developers or JavaScript developers, or hopefully TypeScript developers, to build your own AI applications and make LLMs context-aware at the same time. We can also look at code assistants, but as most of you have been using those, I'm just going to skip it. Because most of the time I just use it to write tests. And I hope you do something similar because I hate writing tests, and this just makes it easier. So the net of all my talking has been building AI applications is just like building any application. Because there are these abstractions, there are APIs to help you do all of this. And this just made it a whole lot simpler. Because you no longer need to be a data scientist, create your own machine learning models. You just interface with large language models that were trained by big companies that hopefully know how to do this. And the only thing you have to do as a web developer or JavaScript developer is making sure you write code around it to get useful use cases. So that was my talk. Thank you. And if you're around, come and say hi.